we really cover a very broad range of the field, right? So all the way from the geology, the geophysics part and exploration, all the way through mine design, mine operations, health and safety, excavation, blasting, all those kinds of things, all the way through mineral processing.
So everyone thinks of mining as being how do we get things out of the ground. Processing is then how do we turn those into useful resources.
Right now we're getting into geoenergy, petroleum, natural gas, geothermal engineering, everything down a borehole. Where we need to go next is autonomous systems, data analytics, those types of things.
Mining engineers, we're really used to thinking that we get the rock out of the ground, but the mineral processing and the metallurgy folks have to get the good stuff out of the rock, right? And then we've got a lot of waste that has to be dealt with on the environmental side. And so what I think is really interesting and really cool about working with this group of people is that we kind of cover all of that amongst the group.
And one thing that's very interesting about the group here at Virginia Tech is we have a unique capability to work across the full cycle of technology development. So we'll start with an idea at a very fundamental stage and look at basic interactions, maybe how one particle is interacting with another particle. And we have very sophisticated instruments that we can measure that. Then we take the concepts there and try to design a small-scale unit, processing unit in the lab. And maybe we can take and process a gram a day or something, very, very small scale. And most places stop there. But we don't do that here. We take those ideas that we've proven in the lab and we try to take them to the next scale, either pilot scale, small industrial scale, or full industrial scale. And over the time, I think the department here has had a great run of success in producing commercial technologies that started all the way back at that one bubble, one particle kind of interaction.
So there are a variety of ways that research gets funded, but to really make the research relevant, we need close connection with industry partners. And the access to the job site, to the actual operating mines is just absolutely critical.
No, the work we do necessitates industry partners. And if you think about our group, we do a lot of commercial activities. We always start with commercialization in mind. In order to do that, in order to have the ability to do that, you have to have the connections to begin with, to understand what the problems are, and then you have to have the connections on the backside to be able to deliver those solutions. And I think we do a great job of connecting that, but also training the students who will be in that industry position in a couple years.
We really appreciate the cooperation we have with industry. We've got great connections with industry. Over the last 10 years, 20% of all mining engineering grads in the United States have come out of our department. So we've got a network across the country, and that's not only mines and quarries, but also equipment and service and a lot of different areas.
And that's what works out well because the students here learn the state of the art. They learn the new devices and the new technologies, and then they're going to be the ones implementing that into their jobs. So that starts this cycle of this students going to industry, industry people giving back to the students, and that cycle I think is kind of omnipresent in mining engineering.
I really like the prospect of going into health and safety, but as long as my research is built off of or used in some way, whether they say, all right, we know this works, or maybe we know it doesn't work, then I have the potential to help, a lot of people. And so that's sort of what got me interested in grad school here.
I'm doing my master's in mining engineering too, but I'm focusing in ground control in underground limestone mines. Ground control is the area of mining that focuses on designing the underground excavations in a way that these excavations are designed well for the miners to be safe and the excavation to be stable as long as the mining goes through.
Right, so we're using drone technologies right now. We're looking at drone from both photos, videos, as well as laser scanning possibilities in order to map underground environments and really to explore them possibly, or re-explore them if they've been closed down or areas that we cannot safely enter. So we can utilize a drone to fly in there autonomously, map that area, bring that information back, either in real time or post-processing, where we're able then to recreate that environment and see if it is safe.
In my group, we're specifically working on things like continuous DPM monitoring. So this idea that, currently we take a filter sample and a couple of weeks later you might get a result. Wouldn't it be nice to have data that's coming in every few hours or every few minutes?
And currently working on a project in an underground limestone mine to improve the safety underground by modeling this pillar in 3 dimensions and doing an analysis using photogrammetry. We can take a composite of images, put those images together and create a 3D model. We're comparing photogrammetry with laser scanning. Laser scanning is another technology that we've successfully used here in this mine, and comparing the two technologies for industry to use and improve safety in their operation.
As soon as I switched into this major, I knew I wasn't going to leave. The faculty here, the other students in my major, I mean, it really felt like a place that was my own home. In a weird way, the major is fairly small, so it has a close-knit sort of vibe.
The materials that it takes to make those fancy magnets that turn wind turbines, right, that they come from mining. Photovoltaics that go into solar power, they come from mining, right? So we may change the resources that we mine, we may change the rate at which we have to mine, we may change the size of the mines or where they're located, but we'll always have to actually mine natural resources.
Mining's done everywhere, and you can literally get a job anywhere, from big cities to small towns in any country in the world.
How will we design this mine to be environmentally friendly? How will we design this mine to benefit the communities in which we work, right? To take advantage of local skills, to have tax revenues that can be coming back to communities.
And a lot of these critical materials are currently being produced in a way that we would say is not environmentally benign. And so that's a big challenge for us, is doing that, and doing that in a cost-competitive sense. So that's where the creativity comes in, and that's where the problem-solving comes in. And that's where I say, we want to solve these big challenges, and they are, because I think if we want to go forward as a society, we need to have good ways to recover these resources, and doing so in a way that's sustainable, both economically, socially, and environmentally.
And I think that students that are interested in those things would find a good home in looking at mining and minerals engineering. That really is the way that we as engineers want to work, and those are the types of cutting edge things that we're working to do.